Good day to you. This is teacher Leland, Alejandro, and we're going to discuss the unit circle. The unit circle will be discussed on the other screen, and we'll discuss some concepts before we do some problem solving. So let's check on the screen first. All right, let's have the graphing calculator. Here's the unit circle with, of course, the radius is 1 unit of length. That's the radius. That's why it's called a unit circle. Now we're going to study the concepts by making use of the special angles. And we will start from the quadrantal angles and going to the multiples of 30, 45, and 60. So let us define first the concept about the unit circle. The trigonometric identity Pythagorean relation will be used here. And this is the cosine squared. Let me write that. This is actually the cosine squared theta plus sine squared theta equals 1. Okay. Now, this is comparable to this circle over here. Okay, this is x squared plus y squared is equal to 1. And that's exactly this circle, a circle with a radius of 1. Now, this means x coordinate is equivalent to cosine of the angle theta, and the y is equivalent to sine of the angle theta, where angle theta is a standard position angle. So the standard position, of course, the initial side starts with the positive side of the x-axis, and then it can rotate counterclockwise or clockwise. Okay, so for example, this is the initial side, then this will be the terminal side. And the angle theta is, of course, this angle here. There. And this is said to be, the angle is in standard position. So this is the 0 degree, and then it can go counterclockwise or clockwise. So we will have to make use of this trigonometric identity cosine squared theta plus sine squared theta equals 1, where theta is the angle in standard position. Now, let us have the special angles trigonometric functions. Okay, so the trigonometric functions of the special angles, and we will start from 0 degree. All right, so let's clear these notes here. Now, to see that, we shall put points along the circle, okay, on the circle. So we will start using the trigonometric identity. We will start with cosine squared. Okay, so this will be, of course, let's make use of a point. Cosine of 0, comma, and then sine 0, okay? And you will see the point on the x-axis on the right side. You see that green point, and this has the coordinate 1, 0, okay? So this one has the 1, 0. So this is actually the trigonometric function cosine and sine of the angle 0. And we can actually make a radius from here to the point there. So in this position, the angle is 0 degrees. The initial side and the terminal side coincides. Now, we'll proceed to the 30, okay? All right, the 30, of course, we'll make use of cosine of the 30, of which this one is representing the x, and we will have the sine of 30, which represents the y coordinate, okay? And you see the violet point on the blue circle. Okay, and that actually is for the 30 degrees. Okay, let's see if we can change the color of our circle over here. Say we change it to something like dark, so it will be darker there. All right, and yes, that's it. Okay, now the point of violet is the x and y coordinate with cosine 30 and sine 30 as the coordinates, where cosine 30 is for the x and sine 30 is for the y. So let us have the terminal side there. Okay, now the coordinates of this, we shall write the coordinates of this. Now the cosine of 30, this is actually a square root of 3 over 2, and the sine is of course 1/2 there, and they're both positive. They're both positive in the first quadrant. So the x there is the square root of 3 over 2, and 1/2 is the y. Now let's proceed to the 45 degrees, or pi over 4. We have cosine of 45 and sine of 45 there. And you can see the black point, okay? And we shall provide a terminal side for this. And this is for the 45 degrees. Now the coordinates x and y for this point is also positive. We have a square root of 2 over 2. And then the y is another square root of 2 over 2 there. And then we will proceed to the 60. We shall proceed to the 60, and this will be cosine of 60, sine of 60 there. And you can see the red point, and we shall put the terminal side for the angle there. Now, how about the coordinates? The coordinates will still be positive, and this will have, of course, cosine. That would be the x is 1/2, and the y is square root of 3 over 2 there. That will be for the 60-degree angle. How about the next quadrantal angle, 90 degrees, or pi over 2? Okay, how about pi over 2? Of course, this will be 0, 1, okay? 0, 1. So that will be over here, 0, 1. That will be the x and y for the intersection of the circle with a radius 1, or the terminal side of 90 degrees. Now, we can put a point there using cosine of 90 and then sine of 90 there. And you can see the light blue point on the circle exactly at the 90 degrees. All right, there. Now, we can also provide a terminal side, right, from the center point of the circle. Okay, from the center point of the circle going to the point 0, 1 there. Okay, next is 120. Okay, 120, or 2 pi over 3. Okay, pi over 3 is 60. So 120 is 2 times 60. Okay, so that means 2 pi over 3 in radians. So this is simply in degrees, 120. Okay, and you can see the mark here. You can see the mark there, 120, 150. Okay, this is 180. Okay, this is 210. This is 240. This is 300, 270, 330. Okay, and back to 360 or 0. Okay, all right, so it's not very dark, but you can see the silhouette. Okay, all right, so it's just very light. Okay, so 120, 150, 180, 210, 240. So these are all multiples of 30. Okay, or multiples of 60. Okay, so let's remove the checks. So we will have a cleaner work. All right, there. Okay, next is 120. So all we need to do is provide the next coordinate. Okay, let's scroll. This will now be cosine of 120 for the x and sine 120. That will be for the y there. And you see the green point again. That will be the intersection of the terminal side of the angle with the unit circle. And so this will be the terminal side there. Okay. Now, how about the coordinates of 120? Now, the coordinates of 120 can be determined by using the reference angle 60. Okay, the reference angle is 60. So, reference angle is defined as the difference, okay, of the terminal side with the x-axis. That's the reference. So, in this case, the difference of 120 and 180. Okay, so it will be 60. Okay, all right. So we can make use of the 60 as a source of getting the coordinates. All right. Now, in the second quadrant, the cosine is negative and the sine function is positive. So the coordinates of 120, okay, the coordinates of this point, the cosine is a negative 1/2 there. And the sine function will still be positive, and that will be, of course, square root of 3 over 2 there. That goes to 120. The next is 135, okay? The next is 135, which is multiples of 45 degrees. And we will use the point cosine of 45 and sine of 45 there, okay? And you can see you should see the point there. So this is cosine of 45. No, make that 135. Yes, multiples of 45. So that will be 135 and 135 there. Okay. All right. So you see the point of the second quadrant, the next violet point there. Okay. So over here, there. So this is 135. So this is 3 times the 45. Okay. So the coordinates of this, the x will be negative and the y will be positive. So the coordinates of this will be square root of 2, but negative. Square root of 2 over 2 and negative square root of 2 over 2 there. Okay. All right. So the other one is positive. That's for the sine. Okay. Let me clear out the other one. This must be a positive there. Okay. All right. So that is negative square root of 2 over 2 and a positive square root of 2 over 2. Okay. The sine function is positive in the second quadrant. All right. So the next one is 150. Okay. The next is 150. This is multiples of 30. Okay. So this will be cosine of 150 and sine of 150. Yeah. All right. So this will now be for 150 degrees at the second quadrant. The terminal side will be at the second quadrant. So we shall draw the terminal side there. And the coordinates of this will be, of course, negative for the x and positive for the y. Okay, what are the coordinates for the 150? Of course, this will be negative square root of 3 over 2 and a positive 1/2 there. Okay, all right. You can verify this later using book documents. Okay, all right, for the values. All right, next is the function of 180 degrees can be found, all right, using the unit circle. So this will now be over here. This is now cosine of 180 and sine of 180 there. Okay, and you can see the light red point, okay, almost pink, all right, along the x-axis left side, okay, and we shall draw the terminal side for the 180 there, okay. Now the coordinates of this will be, of course, -1, 0, okay. This will be -1, 0 there. That means the cosine of 180 is -1 and the sine of 180 is 0, okay. All right, next is 210 degrees, okay. This is multiples of 30. This will be located at the third quadrant. Okay, so let us scroll up. Okay, this will now be, this will be the next. Cosine of 210 degrees, sine of 210 degrees. 210 there. Okay, so you can see the blue point at the third quadrant. This is 210 degrees, or 7 pi over 6. Okay, 7 pi over 6. So if you go around the circle, these are the special angles and quadrantal angles. So this is for the 210 degrees there. And the coordinates, of course, the x and y coordinates are both negative, okay? So this will have negative square root of 3 over 2 and negative 1/2 there, okay? All right, that goes to the coordinates of the intersection of the terminal side of 210 degrees with a unit circle. Next is 225 degrees. 225 degrees. This is multiples of 45 again. So we will have the x coordinate and then the y coordinate there. And you can see the light violet point, okay, at the third quadrant, and we'll connect it with the terminal side there, okay. All right, now how about the coordinates of this point? This will be both negative square root of 2 over 2 and negative square root of 2 over 2, the x and the y coordinate. The next angle is 240. We shall determine the location of the point. This will be cosine of 240 and sine of 240. There, you can see a dark point on the third quadrant. This is now the intersection of the terminal side of 240 degrees in standard position with the unit circle there. And the coordinates will still be negative, both x and y. So this will now be, of course, a negative 1/2 and a negative square root of 3 over 2. These are the coordinates of the point on the unit circle for 240 degrees. Next is 270 degrees. We shall have the next one. This is the next quadrantal angle. This is cosine of 270 for the x, sine of 270, I should say. That will now be right there. Okay, you can see the pink point along the y-axis below the origin. Okay, so this is 0, -1. The coordinates of this will be 0, -1 there. So the cosine of 270 is 0. The sine of 270 is -1. Okay, so we shall draw the terminal side there for the 270. The next angle is 300 degrees, okay? 300 degrees. So you see we're going around the circle. So let's scroll up again so that we can see what we are typing. All right. Next, we have the next point is cosine of 300, sine of 300. And that will be the blue point on the fourth quadrant, okay? On the fourth quadrant. And we shall proceed with the terminal side there, connecting with the point. And the coordinates for this, okay? This will have a positive x and a negative y, okay? A positive x and a negative y. So we shall put the positive 1/2 for the x and a negative square root of 3 over 2 there, okay? So this will be the coordinates for the 300 degrees. Next is 315, okay? 315. Okay, so this will still be at the fourth quadrant, and you shall check the point on the fourth quadrant. This will now be cosine of 315, sine of 315. There, you can see the dark point again, and we shall connect it with the terminal side or radius from the center 0, 0 to the point. And then we shall write the coordinates of this point, which is actually the trigonometric function cosine and sine of 315. So this is actually positive square root of 2 over 2 and a negative square root of 2 over 2 there. And then the next one will be 330. This is another special angle, of course. So this is cosine of 330 and sine of 330 there. And you can see the pink point along the unit circle there. After I have typed it, and here is the radius, and the coordinates for this will be, of course, positive for x and a negative for y. Okay, this will have a positive square root of 3 over 2. Let me clear my number 2 there. This will be, of course, 2 and a negative 1/2. Okay, negative 1/2 there. Okay, so these are the coordinates of the special angles. Okay, 0 in radius. This will be in degrees. I mean, in degrees, this will be 0, and then 30, 45, and then 60, and then 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and back to 0. Okay. All right. So these are the coordinates of the points on the unit circle. And these are actually the trigonometric functions of those angles, the cosine and sine trigonometric functions of those special angles. So if we go around in degrees, those are the degrees, okay? All right. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and that'll be 120 degrees at the second quadrant, 135 degrees on the second quadrant, and then we have 150 degrees on the second quadrant, and then at the left side of the x-axis is the 180, okay, and then followed by 210 degrees at the third quadrant, 225 degrees at the third quadrant, and then that'll be 240 degrees on the third quadrant, and then the lower part of the y-axis that points downward south, that will be 270 degrees. Now we're in the fourth quadrant. The next will be 300 degrees, followed by 315 degrees, and then the last one is 330 degrees. And we're back to 0 degrees or 360. Okay, so this will be the important values of the cosine and sine of these special angles. Now, we can use this now in our problem solving. Okay, all right. And so we shall proceed to the problem set. Okay, let's check on the problem set on the other screen. Okay, this is it. All right, let's start from the first number. Let me try to scroll it. So this is the unit circle lecture examples. Solve the following. This is number 1. Okay, here's number 1. For which value of theta is sine theta equal to 1? Okay, all right. We can check that in the quadrantal angles. Sine theta is the y value. So the points that you see with a y value of positive 1, that is the answer. Okay, and of course, it's very clear over here. There. And that belongs to pi over 2. Okay, pi over 2 is the value of the theta. Okay, so we're after the angle, so this is pi over 2. This is in radians. Now, this is also equal to 90. This is in degrees. Okay, this will be in degrees. There. Okay, all right, so that goes to our first number, and that's the answer. Because the question is the angle. Which value of theta is sine theta equal to a positive 1? Okay, and we know sine theta is a y value. Okay, it's a y value. Cosine is an x value. So if ever you see the coordinates y value of positive 1, okay, then that's the angle. Okay, and we can find that over here, of course. Over here, there. Okay, so that means from the standard position, okay, it's this value. Okay, it's this value angle, like that. Okay, so that's pi over 2. All right, let's continue with the next number 2. All right, let's clear the screen and proceed to the next number. So the answer here is 90 degrees, or we want it in radians, it's pi over 2. All right, let's continue with number 2. Let's scroll downwards. Here's number 2. For which value of theta, so we're looking for another angle, cosine of theta is negative 1. All right, we know that cosine is for the x. Okay, we're talking about the point cosine theta, sine theta in the unit circle. This is actually x, and this is the y. Now, we're looking for something like negative 1 in that, okay, like that. So that looks like pi. The angle is pi radians, or 180. It's over here. There. The x value there is negative 1, and that points to the 180, okay, there. So that means the answer, we're looking for the angle 180 degrees. And this is equal to pi radians. There. So this is the answer. There. Okay, so the answer for this question, the value of theta is 180 degrees, or pi radians. All right, let's continue with the third. Let's proceed to the third. Let me clear the screen and scroll. All right, so we scroll downwards. Here is the third. Okay, here's the question. What is the value of cosine theta in the diagram below? Okay, in the diagram below. So which theta are we talking about? Well, it's over here. There's the theta. It's over here. There. All right. So that means we're looking for the cosine of this angle, which is clearly this one, the x value. Okay. That's the x value of the point, because the point is 5 over 13, 12 over 13. There. That means this is the cosine theta, and this is the sine theta. The question is the value of cosine theta. Therefore, the answer is 5 over 13. That's the answer. Okay, the value of cosine theta. All right, that goes to our number 3. Let's continue and proceed to the fourth. All right, proceed to the fourth. Let's scroll to the fourth. Here's the next question. What is the value of sine theta in the diagram below? Okay, again, the theta is this angle here. Okay, this angle, and that's the theta there. Okay, and so the question here this time is the value of sine theta. And there's the point over there. This must be the cosine, and this will be the sine. The sine is for the y, okay? So that means the answer is square root of 3 over 2. Sine of theta is square root of 3 over 2. There. That should be the answer, okay? All right. So what is the value of sine theta? It's there. You can see the point, all right? The intersection of the terminal side with the unit circle, and that is where the theta is, this angle theta, okay? And so we're asked to get the sine of theta, all right? So the unit circle is very useful in finding the trigonometric function sine and cosine using the unit circle. So this is the answer for number 4. Let's continue with the next number, number 5. All right, so number 5 will be over here with a diagram again. What is the value of tangent theta in the diagram below? Okay, all right. First, we will find where the angle theta is. So this is actually from here going there. Okay, so the angle theta, the terminal side is on the 3rd quadrant. And you can see the coordinates x and y there. Okay, and this is actually the cosine, and this is the sine there. Okay, like that. All right, and so how do you get the tangent theta? Okay, how do you get the tangent theta? Actually, if you study the right triangle in the unit circle, if you study the right triangle in the unit circle, okay, like this, let us use something straight. If you study the right triangle in the unit circle, like this, and imagine that this is the point on the unit circle, and this is the circle itself, okay, and this is your x and y there, okay, and this is your radius 1. This is your radius 1. This is the center of the circle at the origin. This is actually your y length. This is your x length, and this is actually your theta, like that. This is the 0-degree initial side. And so if you're after the tangent, it's like opposite side divided by adjacent side. There. So it's y over x. So tangent of theta is y over x, like that. And so this means you will use the y, and y is the sine theta. Okay, and you will use the x, which is the cosine theta. And this means tangent of theta is equal to y. All right, our y in the diagram, that will be sine theta, okay? And that is negative square root of 2 over 2. negative square root of 2 over 2, and then our x is negative square root of 2 over 2 also. And this is exactly positive 1. Okay, so the value of tangent theta required here is 1. Okay, so this is the answer there. So that's it in the third quadrant. And that is actually for 225 degrees, okay, at the third quadrant. And it's multiple of 45 degrees, okay. So the tangent of the third quadrant is positive, okay. So the answer there is exactly 1, okay. Tangent of theta equals 1. That's the answer there. All right. So next, number 6. Let's continue with number 6. And so we proceed to the next. We'll scroll, and here is the next. Okay, we shall read the problem. The terminal side of an angle measuring 4 pi over 3 radians intersects the unit circle at what point? Intersects the unit circle at what point? Now, we will use the knowledge we discover in the discussion, okay? So we shall try to find the answer. First, what is 4 pi over 3? Pi over 3 is equivalent to 60 degrees. So 4 times 60, that's 240 at the third quadrant. So if we are going to do some diagram, let's put the y-axis and the x-axis there. All right, and then let's put a circle. So say, for example, our circle is like this. There, okay. Now, where is our 240 or 4 pi over 3? Okay, 4 pi over 3 will be somewhere here. There, okay. That's 4 pi over 3. And this is our angle theta there. That's our angle theta. Okay, now we can do a reference triangle there. Now the reference angle is, of course, 60 degrees. The difference of 240 and 180. Okay, that's the difference. Okay, angular measurement, the terminal side, and the x-axis, and that is 60 degrees. If you're going to draw your reference triangle, okay, it will be including a 60-degree angle like this. There, okay, and imagine this is your radius 1, all right, and this is actually the x value, all right. This is the x value, which is actually a 1/2 negative, okay, and then this is the square root of 3 over 2 negative there, okay. All right, this is actually the cosine theta, and this is the sine theta there, okay. So we're after the coordinate, okay. Your circle is, of course, here like that, okay, and this is the point there, okay. All right, and we're after the point, okay. 4 pi over 3 radians intersects the unit circle at what point? All right, this is what we studied a while ago there, okay. So the point here is negative 1/2 and negative square root of 3 over 2 there, okay. So this is the answer there, okay. So the answer is negative 1/2, that goes to the x, and then negative square root of 3 over 2, that goes to the y, okay. And these are the coordinates x, y. Okay, we're looking for the point. And this is what we studied in the first screen. Okay, so this is the answer. We're after what point? Okay, 4 pi over 3. Okay, all right, so this goes to our number 6. Let's continue with number 7. All right, so here's the next. Here's number 7. Okay, let's read. The terminal side of an angle measuring 7 pi over 6 radians intersects the unit circle at what point? Okay, again, we will try to draw a circle, our unit circle, starting with the y-axis, and this is our x-axis, okay, and we provide a circle, all right. Uh, let's make it larger, okay. Let's make it larger. Okay, so let me clear that. Let's do a larger circle, starting, say, right here, going there. All right. Okay. Now, where is 7 pi over 6? Where is this? Pi over 6, this is 30 degrees. Okay. So if you're after 7 of these, that's 7 pi over 6. This must be 210 degrees. Okay. All right. You can figure that out by a drawing. Okay. 30, 60, 90, and then this will be, of course, 120. Okay. This is 150. This is 180. All right. 180. And this will be the 210. Okay. And that's 1, 2, 3, 4, 5, 6, and here's your 7th. Okay, so that will be multiples of 30. That's 210 degrees. Okay, if you're going to visualize the reference triangle, okay, it will be this triangle there. This will be the triangle, and it will look like this. Okay, if you enlarge it, that reference triangle that we can use looks like this. There. And the reference angle, the angle made by the terminal side and the x-axis is 30 degrees. So this is 30 degrees. There. And so we're looking for the point. And this is our 1 unit from the diagram. This is 1 unit, okay, in the diagram. And that means this is the radius 1 unit. All right. What is our x and y here? The x and y will be both negative, okay? And our x is square root of 3 over 2. And this is negative, okay? And our y is 1/2, which is also negative there, okay? All right. And so our point will be, of course, the point here. Okay, the point here, of course, is negative square root of 3 over 2. That will be for the x, and negative 1/2, that will be for the y. Okay, we're talking about this point here, this point. There. All right, let me exaggerate the point. All right, there. That's the point. We're looking at that point. Okay, let me remove the checks. Okay, so it will look a little neater. All right, so it looks neat. All right, there. Okay, this is our, of course, y axis and x axis. This is our center of the circle origin. Okay, we're after 210 degrees. Okay, that's 7 pi over 6. All right, so this triangle is the larger version of this. Okay, the larger version of this. Okay, all right. And so looking at the required point, we're after this point here, this point there. And the coordinates of this is negative square root of 3 over 2 and negative 1/2. Okay, remember the sine and cosine of the angle in the third quadrant are both negative. Okay, so this is the answer. There. Okay, all right, so negative square root of 3 over 2, that's for the x. Negative 1/2 is for the y. Okay, again, we shall write it once more. The required point is negative square root of 3 over 2, negative 1/2. Okay, these are the coordinates of the point. Okay, on the unit circle, intersecting with the terminal side of 7 pi over 6. Okay, so that's negative square root of 3 over 2 and negative 1/2. You can memorize the unit circle's coordinates, okay, from 0 up to 330. Okay, so 0, 30, 45, 60, 90. Okay, next is 120, 135, 150. All right, and then the straight angle 180, and then we're now on the third quadrant 270. Okay, so if you go around it, the next one is 225. The next is 240, and then the next is the quadrantal angle 270. That's south. And then if you continue to the fourth quadrant, it's 300 degrees, 315, and then 330, and you're back to zero. Okay, or 360. All right. So you have to memorize that in order to make use of the unit circle. Okay. All right. All right. So this will be the answer for number 7. We'll continue with number 8. So this will be number 8. Let me scroll down, scroll up. All right. So this will be, of course, the terminal side of an angle. Okay. The terminal side of an angle measuring 5 pi 3 or 5 pi over 3 radians intersects the unit circle at what point? Okay, intersects the unit circle at what point? Again, we can do a little diagram. Okay, let's imagine our y-axis. This is our x-axis. We put some labels there. And then we draw our unit circle. Let's draw our unit circle. All right. Okay. All right. So this is our unit circle. Our given is 5 pi over 3. So what is 5 pi over 3? Let's start with pi over 3. Pi over 3 means 180 over 3, which is 60 degrees. There. Now, what is 5 times of this? Okay, 5 times. That means 300. So 5 of pi over 3. That means 5 times 60, which is clearly 300 degrees at the fourth quadrant. Okay, so where is this? It will be the additional 30 after 270. So it will be like this. There. Okay, there. So this is the angle theta. From the standard position, like that. All right. And this is actually 300 degrees. Okay. There. All right. So we're after what point? Okay. We can draw our reference triangle. Okay. So this will be our, let's draw a right triangle there. Okay. Like that. And we're looking for this point here. We're looking for this point. Let me exaggerate the point there. That's we're looking for the coordinates of that, okay? So if we're going to enlarge the triangle, that is actually a 30, 60, 90 triangle, okay? Or yes, 30, 60, 90 triangle. So it will look like this. If you exaggerate that, there, this is the radius of the circle. This is the radius of the circle. The angle here is, of course, 60. There, the reference angle, okay? The reference angle. You know the definition of reference angle, it's the difference of the terminal side and the x-axis, okay? So we have here 60, okay? This is our 0, 0, the center of the circle, okay? We're looking for this point here, the value of the coordinates at that point, okay? Now, the x value, of course, is cosine of theta, okay? Cosine of theta, and that is a positive, okay? That is a positive over here. It's a 1/2 there. And then the y value of the point, okay? The y value, of course, at the fourth quadrant is negative, and this is negative square root of 3 over 2 there. So we can see clearly the coordinates of this point, the coordinates of this point, okay? All right, what are those? Okay, we shall write it down here. Dx is the positive 1/2, okay? And the y is a negative square root of 3 over 2, there, okay? That's the coordinates of that point, okay? Imagine the circle is here, okay? There's the circle there, like that, okay? And yes, there. Supposed to be like that. I just made it larger, okay? All right, so the coordinate of that point is 1/2 negative square root of 3 over 2. And this is the answer, okay? All right, that goes to our number 8. Let's continue with number 9. All right, let me clear the screen and scroll up. I hope this one's clear with you. All right, next, number 9. All right, number 9. There, I over scrolled. All right, so the terminal side of an angle measuring 11 pi over 6 radians intersects the unit circle at what point? Okay, again, we shall try to attempt to draw our system. This is our y-axis. This is our x-axis. All right, we have a circle. Okay, let's draw our circle. So let me draw it from here, going there. Okay, there. All right. Okay, where's 11 pi over 6? Pi over 6 is 30. Pi over 6 is 30 degrees. Pi over 6 is radian units. Okay, pi over 6 is radian units. All right. Now, 30 is in degrees there. Okay, now 11 of this, 11 pi over 6. And that means 11 times 30, okay? And that's 330 degrees there. And where is this? Okay, it's this angle here, there. All right, so this is 330 from the standard position going there, like that, okay? So the reference angle here, the reference angle is 30, okay? So if we will draw again the right triangle, okay, we will have a horizontal and a vertical, okay, like that. The horizontal being part of the x-axis. This will be something that looks like this if we're going to exaggerate it. Okay, like this. And the 30 degrees that I'm talking about is right here. The reference angle. Okay, the angle made by the terminal side of 330, okay, with the x-axis there. And you can imagine this larger drawing such that this is the y-axis and this is the x-axis there, okay, like that. All right, and this is the center of the circle there, okay. And where is the circle? Of course, this is the circle there, like that, okay, part of the circle. Now we're looking for these coordinates here. Let me exaggerate the point there. We're looking at that point. What will be the coordinates of that point? All right. Okay. So again, this is the radius equal to 1. This is the radius equal to 1. And this is a positive value square root of 3 over 2. This particular side, okay? This particular side is square root of 3 over 2. This particular side is a negative 1/2 there. And so you can very well, let me write my square root clearly, okay? This is square root of 3, okay? Square root of 3, all right, square root of 3 over 2. And that'll be for the x, negative 1/2 for the y. So the coordinates here, this will now be square root of 3 over 2, comma, negative 1/2. This will be the x and y coordinate of the point right here. There, okay? All right. I exaggerated the point. All right, so this will now be square root of 3 over 2, negative 1/2. And you can check this out in our discussion in the first screen. These are the coordinates we wrote, okay? So this is the answer, okay? This is the answer. These are the coordinates of 330 degrees made by the terminal side of 330 degrees with a unit circle, okay? So that's the answer. All right, so that will be for our number 9. Let's continue with number 10. All right, so let me scroll to number 10. Okay, here's number 10 with a diagram, okay, with a diagram. The radius of the circle below, okay, again, this is a unit circle, okay, this is a unit circle. So the radius of the circle below intersects the unit circle at 513, that will be for the x, and negative 12 over 13, that will be for the y, okay? We're talking about this point here, there, okay? All right, what is the approximate value of theta, okay? What is the approximate value of theta, okay? What's the approximate? All right, so the theta here is the large angle there, okay? We're looking for that particular angle, theta, okay? You can see the diagram with the blue Greek letter theta. There, the Greek letter theta. Now, we're after that angle. So surely it's more than 270, okay? It's at the terminal sides of the fourth quadrant. So what is this angle? Okay, we shall try to determine the trigonometric functions, and then we shall be able to compute for the angle. First, we have 513. That would be the cosine of the angle, okay? This will be the cosine of the angle, 5 over 13. So we have cosine of theta, that is equivalent to 5 over 13. There, and it's a positive. The sign is, of course, negative in the fourth quadrant, and this is equivalent to negative 12 over 13 there, okay? So our reference triangle, we shall attempt to draw it, okay? All right, in the diagram, we can start projecting the triangle. It will be this as the hypotenuse. The radius is the hypotenuse with the length of 1. This will be the x. This will be the y. Okay, this will be the y, like that. Okay, so this will be, of course, the x. This is the y, and this is the r, which is equivalent to 1. Okay, if we make our right triangle larger over here, okay, it will be something like this. Okay, and this is our y. Okay, and this is our x. Okay, now this is the r. Our r is the radius of 1. Okay, our y is the sine theta. This is negative 12 over 13. There. And our x is the positive. Okay, 5 over 13. There. All right. Now, let's get our theta prime first. This angle. It's a reference angle, okay, which is clearly, if we use tangent function, we'll be able to get the values, or uh, the 5 over 13 as the cosine, and negative 12 over 13 as the sine. Okay, all right, we can always use those. All right, and so we can make use of our scientific calculator for that, and then we shall try to see how it's going to be. Since we know the cosine here is 5 over 13. Okay, we have here cosine of theta is 5 over 13. Then we shall find theta, which is equivalent to inverse cosine with a negative 1 there, inverse cosine of 5 over 13. There, okay? And so we will be able to compute for our angle, okay? This is just an acute angle, okay? And this theta will be our theta prime, okay? Okay, take note. This is not yet the final answer. It's the angle in our triangle, okay? Because we're after the larger angle, so we will get the difference later with 360. Okay, so we shall get this angle, subtract it from 360 to get the final answer. All right, so let us compute first. This will now be inverse cosine 5 over 13, and this is 67. Let us write complete digits. 67 380 13505 13505 in degrees. Okay, now we're after the larger angle. Okay, this will be for our final answer. Okay, our theta will be, all right, this will be for angle theta. Theta is 360 minus theta prime. There, okay? All right, so this will be like 360 minus, okay, 67.38013505. There. All right, so theta will be, all right, this will now be 360 minus 67.38013505. So minus 360, and this will be, of course, 292. This is 292.6198 649. All right, this will be in degrees. So the final answer, rounded to the nearest tenth, is 292.6. Okay, so this will be our theta is 292.6. 292.6 degrees. That's a 2. Okay, 292.6 degrees. Okay, there. This will be our final answer. It must be larger than 270 because this is located at the fourth quadrant. So this is it for our number 10. This is our last number. So I hope you were able to learn from the examples and discussions in the first screen. So try to memorize the unit circle, okay, so that it will be easier to do assignments and quizzes. All right, so this will be all, and see you later. God bless you.